Hi, so we are going to continue for the discussions for this chapter. So let's look at this question. So first, which of the following shows the ionization of the ammonia in water? So the first thing you need to know is that what is meant by ionization in water. So you can understand it like this is the ammonia will dissolve in the water and produce the ion form, which is we can write the chemical equation like NH3 plus the H2O and then form the ammonium ion with the hydroxide ion, one positive charged ion and another negatively charged ion. So first, look at A. This is actually still the molecule form. It means that this ammonia is still present in the ammonia form. It does not ionize since all these particles are bound to each other. And then let's look at B. So we observe that this is a big circle and we have the hydroxide ion. So this big white circle is actually the ammonium ion. So the answer is B. So for C, it's still like this is the NH3 molecule because this big circle is N and then the three small circles is the H. So it makes sense, right? And then this is the hydroxide ion. So next D. This is N by OH, so it does not make sense because when the ammonia dissolves in the water, it will produce the ammonium ion and the hydroxide ion. Okay, so continue for the next question. Diagram 4 shows the types of the particles in the solution. So we have this beaker and inside it we have the ammonium ion and the hydroxide ion. Which of the following represents the type of the solution shown? So we have strong acid, weak acid, strong alkali, and weak alkali. So for your information in your syllabus, you must always remember that ammonia is the weak alkali. This is what you need to remember. And the equation you need to remember is NH3 plus the H2O forming the NH4 plus, which is the ammonium ion with the hydroxide ion. This is the equation. Okay, next. Which of the following is a weak alkali? So the answer is C because it involves the ammonium. And then for your information, lithium hydroxide, sodium hydroxide, and barium hydroxide are the strong alkali. Means that they ionize completely in the water. Ionize completely in the water. Means that it will give out 100% hydroxide ion when it dissolves in the water. Next, which of the following terminology for chemical substance? Terminology means the naming. Which of the following terminology for the chemical substance that ionize partially? So the keyword is ionize partially in the water to produce low concentration of the hydroxide ion. Low concentration of the hydroxide ion. So the answer is weak alkali because we need to know that for the hydroxide ions, it is produced by alkali. So how about if I ask you what is the what substance will produce the hydrogen ions? So hydrogen ions will be produced by acid. And then it says that it ionized partially means that it only dissolves 5 to 20%. This is just a rough approximate, so maybe even less than that. So the answer is weak alkali. So next question, which of the following is correct about weak alkali? We need to find the statement for the weak alkali. So first, if we say this is a weak alkali, means that it only ionizes partially in the water to produce the hydroxide ion. So let's go through the statement one by one. It has a pH value of 14. No. For information, this is the pH scale. And then we have the 7 as our intermediate. So when we going to the right, means that it is a strong alkali. If we go to the left, which is until 0, this is a strong acid. Okay, B. Ionized partially in water. Yes, this is the correct statement. And then C. It does not react with alkali. Okay, I guess it wants to write it does not react with the acid, not alkali. This is typo. No. It will react with the acid to form salt and water. And the concentration of the hydroxide is high. No, this is low. Because it only dissolves in water a little bit, which is ionized partially. So the concentration of the hydroxide ion that produced will be lower. If we want the concentration of the hydroxide ion is high, it should be strong alkali. Okay, next. Also the same question, which of the following statement is correct about the weak alkaline solution? So no, it does not have a pH value of 13, maybe 8 to 10 like that. And then B, ionized partially in water. This is the answer. Concentration of the solution is low. What do you mean by the solution? You should say, or we should say it is the hydroxide ion, right? Concentration of the solution low. It does not make sense. And then D, it does not react with acid. No, it reacts with the acid. Okay, next question. Which of the following particles in the ammonia is responsible for these alkali properties? So today we want to test which particles in the ammonia solution, which is NH3, responsible, which means it shows the alkali properties. So always remember to write this equation out, which is ammonia reacts with the water, give out the potassium ion and the hydroxide ion. So this is the ions that will show the alkali properties. So the answer is B, hydroxide ion. Next question is related to the syllabus subtopic 6.2, which is pH value. Okay, the milk of magnesia can relieve the gastric pain. It neutralizes the gastric juice in the stomach. What is the pH value of the gastric juice? So for your information, in the gastric juice, we have chemicals known as the hydrochloric acids, which we write it as the HCl. So it is a very strong acid. And the main function of it is to like kill the bacteria and then stop the and then starts for the protein digestion. So the answer is A, since it is a strong acid. Okay, next question. Diagram 18 shows the observation when the hydrochloric acid, okay, this is the acid, is added to 20 cm³ of 0.1 mole per dm³ of sodium hydroxide solution. So we have this sodium hydroxide as our alkali, which is stripped with the phenolphthalein indicator. Okay, this is the pH value. This is the diagram for it. So we know that the reaction between acid and base, alkali react with acid, will produce salt and water. So water is neutral, so it has a pH value of 7. And then salt is not acid or alkali, so for sure it will also has a neutral pH. So what is the pH of the colorless solution of X? So the answer is 7. Not 0, not 1, not 13. Because after you put the acid and you put the alkali inside, and then you add the phenolphthalein indicator, and then you shake it, it will become a colorless solution. So for information, this phenolphthalein indicator is actually pink color at first. And after the alkali and acid react with it, it will become colorless. And this colorless observation is usually indicates that the reaction is completed. Means that there's no more acid and alkali present in the conical flask, only left with the salt and water. Okay, next question. Diagram 10 shows the reading of the pH meter when the probe is dipped into the M hydroxide solution. Okay. So we need to calculate for that. First, we just write. Let us write the equation out first. So this M will actually give out the M plus M2 plus with 2OH. We need to balance the equation first. Then we want to find what is the molarity, which is the concentration of the solution, right? So we have, this is actually a alkaline. So we are not going to look at the pH, okay, because pH is for acid. But we want to find, but today the solution given is the alkali, so we need to find the pOH. So for information, the first thing we need to know is that pH plus pOH equals to 14. So we have pH as 12, so our pOH will be 2, right? This is very simple, yeah? And then we want to use the information to calculate for the concentration of the hydroxide ion, isn't it? This is another equation. So first, this is our first chemical formula, and then second chemical formula is this. This is the first, this is the second. And then since we get this pOH2, and then we just sub into inside, right? So our concentration for the hydroxide ion will be how many would be? It would be 10 to the power of -2. And then since this equation already gives us the 2OH, right? So actually we need to divide it by 2. So our answer would be, A. Okay, next. This is the questions related to 6.3, the acid strength and alkali strength. So let's look at the first question. Which of the following explain why the pH value of 0.1 mole of the hydrochloric acid is lower than the ethanoic acid? So the things that you might observe is that for this hydrochloric acid and the ethanoic acid, they actually have the same concentration, but the question is asking why. So you need to give the reason. Reason for what? Reason for the pH value, why the pH value for the hydrochloric acid and the ethanoic acid is not the same, even though the concentration is the same. So first thing you need to know is that the hydrochloric acid is actually a strong acid. Means it produces 100% of the hydrogen ions when it dissolves in water. And then ethanoic acid is a weak acid. Means it does not give out 100% hydrogen ion. So let's look at the A, B, C, D one by one. A. The ethanoic acid dissolves completely in water. No, it does not dissolve completely in water. It dissolves partially in the water. B. The degree of ionization is higher. No, the answer should be lower, because it is a weak acid, so it ionizes weakly, partially in the water. C. The concentration of the hydrogen ions in the hydrochloric acid is higher. Yes, C. The hydrochloric acid has less number. No. This is strong. So since the concentration of the hydrogen ions in the hydrochloric acid is higher, because it can give out 100% of the hydrogen ions, therefore the pH value is not the same, and the pH value for the hydrochloric acid is lower than the ethanoic acid, because you need to relate it with this formula, which is pH equals to negative log 10 the concentration of the hydrogen ion. So when this concentration of the hydrogen ion is high, so you will get the low pH value, and this means that the acid is very strong. This is the relationship between the concentration of the hydrogen ions with the pH. Okay, next, also the same question. Which of the following explains why the pH of the 1.0 mole per dmK of ethanoic acid is higher than? So now it is higher. Ethanoic acid, why the pH is greater than the hydrochloric acid? Okay, so let's look at the question one by one. Ethanoic acid, no, it does not dissolve completely, it is partially. Degree of ionization is lower, C. Okay, B is lower, C. Concentration of the hydrogen ion is higher, okay, C. D, the number of hydrogen ion per molecule in the hydrochloric acid is lower, no. Okay. Next question, which of the following has a high pH value? So you want high pH value, right? And our pH value start from 0 to 14. So it means that it wants us to find the substance which is strong alkali. So the answer is D. Yeah, okay. Ethanoic acid is a weak acid. Maybe it has a pH value of 5 to 6. Okay. So ammonia may be 7 to 8. And then the potassium hydroxide is 13 to 14. So you need to remember that this is just a general knowledge for, do you know what is weak acid, weak alkali, strong acid, or strong alkali? Okay. Next, table 2 shows the pH value for 4 alkaline solution. This is the pH value for 4 alkaline solution. So it means that W, X, Y, Z are alkaline. So which of the solution has the highest hydroxide ion? So the answer for sure we can already cancel out X and Y, right? It's either the pH value with the solution with the lowest pH value or the solution with the highest pH value. So if you know that, actually when pH which is start from 0 to 14, right? So when you get the number closer to 14, actually means it is a strong alkali, right? So if the number is nearest to 14, it is a strong alkali. So this strong alkali means that it can ionize 100% in the water to produce hydroxide ion. Remember, for the alkali, it is hydroxide ion. But for acid, it produces hydrogen ion. This is different, right? So we want to find solution with the highest concentration. Actually, it wants us to find the strong alkali, right? Strong alkali. This is how you are going to dissect the question one by one and find the hints and concept behind it. So the answer is D. Okay, the answer is D. Okay, next. There are 4 solutions with different pH value. Which solution has the highest degree of dissociation in water? So let's look at the question we have. Okay, we have solution with pH 6. We have solution with pH 1. We have solution with pH 3, and we have solution with pH 8. So yes, just repeat the same thing. For pH, we have the smallest value which is 0, to the largest number, which is 14. So going to the left, and we have the 7 as our intermediate, which is neutral. So when going to the left, when going towards the left, we will get strong acid, right? Going to the right, we will get strong base, strong alkali also. Yeah, the same thing. So let's label the number one by one. So we have 1, we have 6, we have 3, we have 8. So obviously we only look at the one that is more nearer to the left, right? So the answer would be 1. The possible answer would be 1 and 3. But 0 is the smallest values for strong acid. So we need to choose the smaller number which is nearer to 0. So between 1 and 3, we will choose the 1. So the answer for this question is solution Q with the pH value 1. So this solution Q is actually a strong acid. Yeah, because it has the smallest pH value. Okay, let's continue with the last questions for this video. This table is give us the concentration and the pH value of the hydrochloric acid HCl and the ethanoic acid CH3COOH. So we have 2 types of acid. Okay, still the same thing. They always like to ask, I have 2 solutions with the same concentration. However, I get the pH value which is different. One is smaller, one is bigger. So it's asking you to find the true statement for both acids. So it's just like the previous questions that we have already discussed. So first, 1. Hydrochloric acid is weak acid, but ethanoic acid is strong acid. No, this is wrong. Hydrochloric acid is always a strong acid, while ethanoic acid is a weak acid. 2. Second, concentration of the hydrogen ion is higher in the hydrochloric acid compared to the ethanoic acid. Yes, 2 is correct, but 1 is wrong, so we already can cancel out A and B. C. The third, the degree of the dissociation of the hydrochloric acid in water is lower. No, it should be higher. It means that the hydrochloric acid dissolves 100%, but this ethanoic acid does not dissolve 100% in the water. So 3 is also wrong, so the answer is 4. So let's look at 4. Both acids can neutralize an alkali to produce salt and water. Yes. So for your information, no matter it is strong acid or no matter it is strong acid or weak acid, it can react with the alkali to produce salt and water. It doesn't matter as long as it is acid. So same goes to alkali. Today, no matter it is the strong alkali or weak alkali, it doesn't matter, it still can react with the acid to produce salt and water. And this process which produce salt and water by the reaction between acid and alkali is neutralization. So I think this video will end here, and I will see you in the next video.